The LI for this lesson is to be able to apply Newton's second law to vector forces and acceleration. Now this is really similar to last lesson, apart from this time we are using vectors. So what we've got here is Newton's second law, F equals ma, but this time written in vector form. So I've got F, which is a vector, because we know force can be a vector, equals m, which is not a vector, that is just a scalar. A, the acceleration, can be a vector. So F equals ma, where the force and the acceleration are vectors. So this is just the vector form of Newton's second law. So we're going to look at example 8. So it says in question, I represent the unit vector due east. So just as usual, I is one unit vector to the right or due east, and j is the unit vector due north. And resultant force 3i plus 8j acts upon a particle of mass 0.5. Find the acceleration of the particle. So, as we just said, Newton's second law is F equals ma. F is the resultant force. I've been told the resultant force is 3i plus 8j. I'm going to write this in column form just because I think it's easier. If you want to keep it in i's and j's, that's fine. 3i plus 8j is equal to 0.5 times whatever the acceleration is. And I'm going to use the p's and q's that they've given me here. Well, all that means is that 3 is equal to 0.5 times p. And 8 equals 0.5 times q. I can rearrange this to see that p is going to be equal to 6 and q is going to be equal to 16. Just check, 0.5 times 6 is 3, 0.5 times 16 is 8. So quite easily, the acceleration, this vector here, the acceleration vector, is equal to 6, 16, and in the I and j form, that's just 6i plus 16j meters per second squared because it's acceleration. So all I've done is given what they've told me about the force and the mass, plugged it into Newton's second law to find out what the acceleration is going to be. Then the next bit is questions that we should be nice and used to right now from the start of this doing mechanics. It's find the magnitude and bearing of the acceleration of the particle. Well, if the acceleration is 6i plus 16j, that looks something like this. So I've got 6 in the I direction, 16 in the j direction, and there's my acceleration vector. If I want to find the magnitude of the acceleration, I'm going to use Pythagoras to find the length of that acceleration vector. So the magnitude of the acceleration is the square root of 6 squared plus 16 squared. That's just using Pythagoras there, which is going to be 17.1, and it's meters per second squared because it's an acceleration. Then to find the bearing, well, I can find this angle here quite easily. That's not the bearing though, because remember bearings must be measured clockwise from north, so really I want this angle here. So if I find theta, then I can just say, well, therefore alpha is just 90 take away theta. I'll do that at the end stage. So let's find theta first. I know that tan theta is opposite over adjacent, so 16 over 6. Theta is inverse tan of 16 over 6. If you can't follow this, you might need to have a flip back to GCSE trigonometry work to remember how to find these intervals. So I'm doing inverse tan of 16 over 6, which is going to be 69.4 degrees. And then that's not our answer number because I want to find out what alpha is going to be. So I need to do 90, so alpha is equal to 90, take away that 69.4, which is going to be 20.6. But remember, we need to put a 0 in front of that because bearings must be three figures. So that is my bearing of the acceleration. Okay, example 9. It says, these forces all act on a particle of mass 3 kilograms. Find the acceleration. Well, again, we're going to just use the vector form of Newton's second law, F equals ma. First, though, we need to work out the resultant force. And we said in a previous lesson that the resultant force is just all of the forces acting on it added together. So to find F, I'm going to just do the first force plus the second force plus the third force. So that is, the first one is 2i and 4j plus minus 5i and 4j plus 6i and minus 5j. Add this together, so I've got 2, take away 5, add 6, that gives me 3 at the top. Then 4, add 4, take away 5, it's going to give me 3j as well. So my resultant force is 3i plus 3j newtons. And I know that F equals ma. So F is 3i plus 3j, m is 3 kilograms, and then the acceleration vector, I'm going to call x and y for now. I need to work out what x, y are. Well, this is really nice and simple. I can see that 3 is equal to 3x, and 3 is equal to 3y. So therefore x is 1 and y is also equal to 1. So the acceleration vector is just 1 meters per second squared. And they don't ask for it in a particular form, so I can just leave it like that. That's perfectly fine. All I did there was I used F equals ma, but first I needed to work out what F was because they gave me 3 different forces. I had to add them together to get the resultant force and then plug it in to F equals ma. Okay, last example. Similar to the one we've just done, it says a boat is modelled as a particle of mass 60 kilograms being acted on by 3 forces. And this time they told us the acceleration, but they need to find P and Q, which are part of this second force here. Well, I'm going to go about it in the same way as before. The resultant force is equal to the mass times the acceleration. And the resultant force is just all these forces added together. So I've got 80, 50 plus 10p, 20q plus minus 75, 100. That's going to be a resultant force. Let's make it a bit neater and tidy. So I've got 80, take away 75 and plus 10p at the top here. So that's just going to be 5 plus 10p. Just neatened up this bit here. Then add 50, add 100 and add 20q. So that's going to be 150 plus 20q. That's my resultant force. So now let's sum into Newton's second law. I know the resultant force, 5 plus 10p, let's stick Newton's on in, 150 plus 20q is equal to the mass, which is 60, times by the acceleration, which they gave us in the question, 0.8 and minus 1.5. So I've got 5 plus 10p on this side, 150 plus 20q, and I'm going to just multiply that. So if I do 60 times by 0.8, that's going to give me 48 here, and 60 times by negative 1.5 is minus 90. Well, now I can quite easily solve for p and q. Here on this top line, I've got 5 plus 10p is equal to 48. If I rearrange that, I'm going to get that p is equal to 4.3. And here at the bottom, I have 150 plus 20q equal to minus 90. And therefore, I will get that q is equal to minus 12. This is just a nice, simple rearranging of equations. You might need to break that down into more steps if you're not confident on skipping straight to the answer. You could always on your calculator as well, but I don't really need to. So those are our 2 answers. We found the values of P and of Q. And we did that by, again, using Newton's second law, F equals ma, where the resultant force was just found by adding all these 3 forces together. Okay, now we've done those 3 examples, you should be able to have a go at exercise 10D.